One does not simply use the word quantum in everyday life. Well, except of course in science fiction movies. But do you have any idea how weird, beautiful and mind-bending the world of quantum mechanics really is? The most fundamental and mind-bending concepts of quantum mechanics is superposition. With contrast to our classical world, in the quantum realm, we can never predict where the particle will be after a certain period of time. We only do have the probabilities of where the particle could be after a certain period of time. And in fact, the superposition concept suggests that as long as we are not observing the quantum particle can be at many places with different probabilities. It does not make sense, but that's how quantum physics is. How do we explain such a motion? Modern problems require mathematical solution. So we take the help of probability theorems from mathematics to help us solve this weirdness of the quantum particles such as electrons. Trust me, the equation is known as Schrodinger's wave equation is really simple. For now, we'll deal with the simple xi. The absolute value of xi square gives us the probability of where the electron could be at a particular time. We do not know for sure where the electron will be, but we do have the probability of where it could be. So as long as we are not watching it, the probability that the electron will be here is 10%, it will be there is 15%, here is 35%, here is 40%. The interesting and confusing part is that this wave equation exists as long as we are not observing the electron. As soon as we observe the electron, it decides to behave normally and we can see it at a definite place and the equation is no longer valid. Say that the wave equation has collapsed. It exists no more. The most famous paradoxes that arise due to this concept is a thought experiment carried out by one of the pioneers of quantum mechanics, Mr. Erwin Schrodinger. And the experiment's name is CAT, Schrodinger's cat. Since I do not own a cat, I will have to conduct this experiment with my friend Bob. Hello. Now what I'm going to do is I'm going to put my friend Bob into this box.
Take it easy.
Along with this poisonous gas. Yeah, this is fake. Now what I'm going to do is I'm going to close the box, of course. Now you might be thinking that as soon as I put the poisonous gas into the box, the poisonous gas will explode and unfortunately Bob will die. According to quantum mechanics, there's a 50% chance that the poisonous gas will explode or the poisonous gas will not explode. Which means there's a 50% chance that Bob will die or Bob will not die. As soon as you open the box, Bob will be dead or Bob will be alive. But in quantum mechanics, since the box is closed and I'm not observing the true state of Bob, Bob is dead and alive both simultaneously. Let's open the box and see how Bob is doing. Bob is fortunately alive. You might be thinking that if we did this experiment in real life, Bob would surely be dead. But here we have considered only us as the observer. There could be many other observers in the box as well who are observing and thus the wave function is collapsing. The observers could be the gas molecules themselves. See how weird and magical the world of quantum mechanics is? The practical applications of the superposition principle can be seen in quantum computers. That's enough for now. Hope you enjoyed the weirdness.